A cloud flow might execute perfectly during small-scale testing, but in high-volume production environments, those same processes can stutter, choke, and corrupt the dataset. These failures are rarely caused by platform bugs. Instead, they often stem from importing ground-up coding habits into cloud-native automation environments. The specific issue is the instinct to initialize, set, and append mutable variables every time data needs to be manipulated. In Microsoft Power Automate, relying on variables for standard data operations is an architectural choice that frequently throttles performance. Building for the enterprise requires a different approach to data flow than the state-heavy methods used in traditional development. There is a distinct difference between how loops are typically built and how enterprise architects design for stateless execution. This shift is defined by one core directive: stop using variables wrong. The bad flow pattern is easy to recognize. It relies on initializing a variable, setting it, and appending to it inside a loop. The correct flow pattern replaces those steps with native data operations like compose, select, and filter array. To understand the value of the green block, we first have to see exactly why the red pattern fails under a concurrent load. Making this transition is what allows a flow to scale predictably in a professional production environment. Consider a standard scenario: extracting specific data points from an array of 5,000 JSON objects. The most common approach is to push that array through an apply to each loop. In Power Automate, initialized variables sit globally outside the loop. This is global state, applying to the entire flow instance. To safely append data, the loop locks the variable, writes to it, and unlocks it before moving to the next item. This enforced sequential processing creates a significant bottleneck during array manipulation. This is why variable-heavy flows often trigger slow performance warnings as the data volume increases. Managing state through a global variable limits a cloud-scale engine to the speed of a single-threaded process. To speed things up, developers turn on concurrency control to force the loop to process in parallel. This specific command instantly spawns up to 50 parallel execution threads, with all of them racing forward to run at the exact same time. But you cannot have 50 parallel threads attempting to append data to one single global variable at the exact same millisecond. This creates a race condition. Because the engine cannot sequence these simultaneous inputs, the threads collide. This results in a hard failure, or more dangerously, data that is written out of order and corrupted. These collisions are the direct cause of the concurrency issues and unexpected values highlighted in our architectural model. Relying on variables forces a choice between slow sequential processing or fast, highly unreliable execution. The alternative is to move toward functional, stateless data operations. Actions like select or filter array don't use a loop. Instead, they process the entire data payload in memory. These built-in actions transform the input and generate an output payload without ever referencing an external state. Since there is no global variable to lock mutate, these operations are inherently thread-safe, removing the risk of a race condition. Data operations that used to take agonizing minutes inside a congested loop can now be completely processed in a fraction of a second. Adopting this stateless approach allows the cloud engine to execute at its native speed. Transitioning your architecture requires replacing specific variable habits with their native action counterparts. This guide outlines enterprise patterns. Replace set variable with compose. For array mapping, use select to remap data instantly. Use filter array to evaluate conditions against the entire dataset. Finally, use join for strings and parse JSON for schemas without nested variables. Understanding these one-to-one replacements is the key to building more efficient systems. These patterns establish a new standard for how we design automation architecture. The enterprise standard is to avoid variables whenever possible in favor of built-in actions. This results in significantly faster execution and eliminates concurrency bottlenecks. Stateless flows also require fewer actions and are easier to maintain since you no longer need to debug race conditions. Mastery of the platform comes from utilizing the engine's native power to process data with fewer moving parts. Review your current production environments. Audit your existing flows for apply to each loops that are only being used to append data. Replace those variable-heavy loops with stateless select and filter actions. Every variable you eliminate makes your architecture more resilient as your data volume grows. Stop using variables wrong and start building automations that scale.